All right, everybody, welcome back. Okay, so first let's talk about what Monte Carlo is. And Monte Carlo is a way of doing statistical analysis essentially just by doing simulation. It sounds like a really fancy name, and in fact, Monte Carlo, as Professor Tsay was talking about, really was named after Monte Carlo, the European gambling capital. But this method basically means, well, instead of coming up with these complicated equations to model things that maybe are really hard to model, why not just do it and just do a whole bunch of simulations and see if you can get an answer? And so we're going to do that. And it turns out that there's a really neat way that you can use Monte Carlo simulation to tie together normal distributions, dice rolls, using something called the central limit theorem. So we're actually going to walk through showing the central limit theorem in practice, which is kind of a neat tie-in between some of the statistics that we're reviewing for this Foundations of Analytics course. So first, a couple of things that we need to know in the Monte Carlo analysis, some Excel functions. There's RAND, which rolls a number between 0 and 1 with a uniform distribution, which just means that numbers like 0.1, 0.01, 0.2, 0.3, 0.9999, 0.7, all of those have exactly the same probability of occurring. There's another function that we use later on called RAND array that essentially is the same as RAND, but it does it a bunch of times for you. So it'll actually call it times the number of rows and columns that you specify and then scale it. And it's really neat because it'll also turn your numbers into whole numbers. So I'll show you this in action. There's percentile. And so percentile is a function that, given a range of numbers, will return to you that the number corresponding to that percentile. So for instance, the 80th percentile between 1, 2, 3, 4, 5, the percentile gives you 4.2. So let's work through that example real quick and see why that is. So at 1, right before 1 happens, you have a 0% chance of getting to any of these numbers. And once you're at 5, you have a 100% chance. So at 0%, you're right at 1, and at 5, you're at 100. And so 5 minus 1 is 4. 80% of 4 is 3 times 3.2. Sorry, you just do the math. And so then it turns out that the 80th percentile is you start at the 0th percentile, which is at 1. And then you go up 80% of the way, which is 3.2. And that gives you to 4.2. So this is a function. You just give it a range of numbers. You say, give me the 80th percentile of this number, and it'll give it to you. We'll look at that in Excel in a moment. And then there's COUNTIF, which is a set of logic, and it basically just does counts for you. And there's two types. There's COUNTIF, and then there's COUNTIFs. And they're related in that COUNTIFs has multiple constraints. So it returns a count where you match all the constraints. So let's look at COUNTIF. So if I gave it a number, 1, 2, 3, 4, 5, and it has a little special syntax, we'll look at it. I wish there were an easy way to explain the syntax, but there isn't. This comes from programming, so if you have a background in programming, you'll recognize it. But if not, don't know a great resource for you. But ask in Slack, ask elsewhere, and people will be able to help you out. But this notation means greater than equals to 2. It wants a string. You have to put it in quotes. And this value here, if I did COUNTIF with these arguments, it's going to return 4. And that's because it wants to find all the numbers that are greater than or equal to 2, which is 2, 3, 4, and 5. 4 numbers, boom, it comes back. Okay, let's go look at Excel. So we looked at some of these earlier. I want to look at COUNTIF. So here's our numbers, 1, 2, 3, 4, 5. And here we have the COUNTIF value. So I'm just going to do COUNTIF on this range, greater than or equal to 2. And lo and behold, we got 4. I'm doing multiple values here. I'm checking for when this range is greater than or equal to 2 and the range is less than or equal to 3. And when I do that, I get 2 because 2, 3 are the numbers that are greater than 2 and greater than and equal to 2, less than equal to 3. You get 2, 3, two numbers, boom. And then the percentile is what we were talking about before. You have 1, 2, 3, 4, 5. We just went through that math and we saw 4.2 is the right number. So we'll use that in our Monte Carlo simulation. So in the next video, we'll actually talk about Monte Carlo, and I'll step you through it.